Okay, so the plan here is I want to go through some examples of just a lot of the log properties and rules that one should pick up from Algebra 2 or college algebra and got reinforced in pre-cal. Just to kind of make these relevant. This is another great place that I just do a bunch of flashcard facts. So if you're not good on your exponent and log rules, I would make some flashcards of all this, and so hopefully they're not overwhelming. Okay, so the first thing we're going to look at is converting from log form into exponent form. So let me give you some sort of exponential statement that we're familiar with. So 2 cubed is equal to 8. So in log form, what this translates to is log base 2 of 8. So the exponent of 2 of 8, so 2 to what power gives me 8 would be 3. Okay. Okay, the next two statements are just really defining what ln and log really mean. So the phrase ln simply means log base e, and log itself is really just base 10. So if you see a log without a number at the base, that just really means we're dealing in terms of 10. Just another side note here, I'm just going to write this down. E itself, everyone knows pi is 3.14. E happens to be 2.71. With some other decimals, it's a non-repeating, decimal. Anyways, so just good to know that. But this next wasn't too many facts off that. Okay, log base b of b equals 1. So where you typically will see something like that is log base 2 of 2 equals, and what would that be? Well, that would be 1. It's when these two, when that number and that number match, that's what the exponent of that thing happens to be 1. So another illustration, log of 10 of 10. What's the exponent of 10 in base 10? That would be 1. Okay. Next log rule. If I'm looking at log of any number, so log base 2 of 1, what exponent of, in terms of base 2, 2 to what power would give me 1? That would be 0. So that's what that property is saying. The next two statements, next two properties are nice in terms of simplifying things down. So if I have, say, log base 3 of 3 to some power, that reduces down to that power. Or reverse that, if I have 3 raised to the log base 3 of some power, that also reduces down to the expression inside the log. And again, if you're not one that recognizes these things, these would be perfect flashcard facts. It also works with ln's, so we get ln of e equals 1, but the ln of e to any exponent, so something crazy here, ln of e to the 2x minus 1, that would reduce down to 2x minus 1. And it goes backwards, so e raised to some power, so e to the ln of something reduces down to whatever that something is. And then we start looking at properties of logs. So inside a log statement, if we're multiplying log of 10, we can break that up, and so 10 being 2 times 5, we could break that up into a sum with the logs. If I'm dividing, so log of x over 2, I could break that up into a difference. So log x minus log 2. And then the last sort of thing, and then we'll just start looking at applications of this, would be if I raise it to some power. So let's do ln of x to the 4th. I can bring the 4 out front. And that's what that says. Okay, so the intention wasn't to demonstrate why this is, just to remind you of the various properties. And again, if you're looking at this going, I don't remember this, I would flashcard fact this and just make sure that if this shows up on a test or something, you just don't forget what the actual property is. Okay, so we're going to just remind ourselves of some various rules and properties that deal with solving equations. So one of our situations is if I'm solving for a variable and the variable's in the exponent form, if I can get a common base, then do it. So for example, I can make 1/4 and 8 have the same base, because 4, just a quick reminder here, 4 is really 2 squared and 8 is really 2 cubed. So I can rewrite both of those sides, the left and the right side, in terms of 2. So with the 1/4, that means I'm going to have a negative in there. So the left side I can rewrite as 2 to the negative 2x, 2 to the negative 2 being 1/4, and 8 I can rewrite as 2 cubed. And then what I'm doing is, and just point out here, I'm not dividing, I'm simply saying the only way that the left side and the right side would ever match is if the exponents themselves happen to match. So then my equation reduces down to negative 2x equals 3, in which case x is negative 3/2. Okay. Same logic applies over to number 2 here. Obviously the base e in terms of everything, so now I'm just trying to use log properties to get it to say e to something equals e to something. So we get e to the x squared equals e to the, well, if I'm dividing by x squared, and bring that up as a negative exponent, so that would be 3x minus 2. And then, just like number 1, the only way that that's ever going to equal each other is if the left side happens to equal the right side. So x squared equals 3x minus 2. And now we're solving a good old-fashioned quadratic. So I'll bring everything over to the same side. So x squared minus 3x plus 2 equals 0. Try factoring. So x minus 2x minus 1. And that works. So x would be 1 and 2 for that solution. Okay, number 3, log base 3 of x equals 4. This is a great time when converting to exponent form would save the day. So we're going to take that to be 3 to the 4th equals x, and 3 to the 4th, I always like to think of it as 3 squared times 3 squared. 3 squared is 9. But anyways, 3 to the 4th is 81. So that was a nice easy one. Okay, now what about number 4? What if your base isn't the same? Well, we can take advantage of one of our e properties in that ln of e equals whatever the exponent is. So if I take the ln of both sides, that will simplify down some of this math for me. Try writing this a little bit nicer. E to the 2x equals ln of 20. And then ln of e to the 2x, well, that's one of our properties. That just reduces down to 2x equals ln of 20. And then divide that by 2, so x is the ln of 20 over 2. And that's a perfectly great exact answer. Okay, so number 5, again, we're looking at log form, so I'm going to take advantage of the fact that I can convert this to exponent form, and that'll give me something a little more familiar with what I'm dealing with. And again, another reminder is if I see log by itself, that really means log base 10 of x minus 2 equals 2. So if I convert that into exponent form, that's 10 squared equals x minus 2. And that's something familiar. So 10 squared is 100 equals x minus 2, and that would be 102 is our answer. Earlier in the directions, I mentioned about check domain restrictions. Just want to remind us, log is restricted in that it has to be positive numbers. So if x is in fact 102, if that's an actual solution, if I put 102 into the initial equation, do I violate any domain restrictions? In other words, does 102 even show up to the party of log? And if I put 102 in there, I get log of 102 minus 2, which is log of 100. 100's a positive number, and so we're okay. 102 is a valid answer. Number 6, we're looking at a situation where I've got log on both sides. Almost. That 2 out front, man, if it wasn't there, we'd actually have the same log to the same base on each side. And luckily, we have a log property that we can take advantage of. So I'm going to bring that 2 up as an exponent of x plus 1. So that'll be log base 3 of x plus 1 squared. Okay, so now at this point, the only way the left side and the right side are ever going to equal each other is if the inner pieces happen to also match each other. Okay, so now I'm just going to solve this type of equation. Alright, so now we just got to think back to maybe our quadratic rules are going to kick in, or maybe foiling. So let's see, if we FOIL this out, I get x squared plus 2x plus 1. And I notice the x squareds cancel out on both sides. I can bring the positive 1 over. So plus 1 minus 1 give me negative 2 equals 2x. And so x would be negative 1. Okay, now let's check our domain restrictions on something like this. So if I bring this up here, I get negative 1 squared minus 1. Kind of show you what I'm talking about. If I bring in negative 1 squared, I get 1 minus 1, which is 0. That's not good. And over here, I get negative 1 plus 1, so I get log of 0. Log of 0 is undefined. There is no, when x is 0, if the function's log, there is no y value that corresponds with 0. If you think back to the log parent graph, there's an asymptote right there. Kind of remind us of this. We're looking at an asymptote. We're looking at an asymptote right there. And our log graph looks like this, right? So when x is 0, you're talking about the asymptote itself. There is no y value that corresponds to that, so this one happens to be no solution. Even though we got a solution, it doesn't work in the real world sense, so we don't keep it. Okay. Last but not least, 7 and 8. So in number 7, we're looking at a minus in between the two logs, and I'd like to bring them into one log, and then I could convert to exponent form. So this would be log of 2x divided by x minus 3 equals 1. And remember that this is really base 10. So if I convert that into exponent form, I get 2x over x minus 3 equals 10 to the first, which is 10. And then I can sort of cross multiply, so 2x equals 10 times x minus 3. 2x equals 10x minus 30. And then if I keep solving there, so let's see, bring the 2 over, put the 30 over there, so 30 equals 8x. So x is 30 over 8, which reduces down to 15/4. And yeah, I should stop and check domain restrictions. So 15/4 times 2, definitely a positive number. And 15/4, let's see, 4 times 3 is 12. So 15/4 is actually bigger than 3. So if I subtract off of 3, we're still good. We're still fine as far as having domain restrictions go. So 15/4 is a valid answer. Okay. Last example, just want to review and throw at you here. I got logs on both sides, but I also have this constant. So the first thing I'm going to do is put the logs on the same side and try to get it to be a single log statement. So log to the 2x plus 1 minus log of x minus 2 equals 1. And I can do the same process as number 7 here. So log of 2x plus 1 over x minus 2 equals 1. And if I convert that to exponent form, I get 2x plus 1 over x minus 2 equals 10. Distribute that in, so I get 2x plus 1 equals 10x minus 20. And we'll bring the x's to the right and the numbers to the other side, so that'll give me 21. So if I add 20, I get 20 plus 1, which is 21, equals 10x minus 2x, so 8x. So x is 21 over 8. And there you go.